Okay, we're going to jump into lesson 4.2 here, which is on arithmetic sequences. I know it looks like arithmetic, right? But in this case, we pronounce it as arithmetic. And let's start with some vocab words. So first, we're going to look at what is an arithmetic sequence. We talked about sequences yesterday as being a list of numbers, and an arithmetic sequence is a specific type of list. So it has a specific pattern in which the common difference is always equal. Okay, and so it's got to be a common difference in that we're adding or subtracting the same number over and over and over again. So let me give you an example here. So something along the lines of 3, 6, 9, and 12, that would be considered an arithmetic sequence because we're adding 3 each term. Okay, we could also do subtraction. So let's see, 4, 2, 0, -2. This would be an arithmetic sequence because we're subtracting the same number over and over and over again. Something that wouldn't be an example would be something like this. Let me give you a quick example here. So 2, 4, 8, and 16. This is a sequence and it has a pattern. The pattern is that we're multiplying by 2, but that is not an arithmetic sequence, not the specific type that we're learning about today. So this would be a different type of sequence, not the arithmetic sequences. So I'm going to go ahead and get rid of that. Okay, and then it says common difference, and this is the difference between terms, and we use the variable d to represent the common difference. So we would put d equals and then whatever we're adding or subtracting over and over and over again. That would be the d value, the common difference. We've got an explicit rule and a recursive rule, just like we did yesterday, and these are specific to these arithmetic sequences. So they've got it written out over here. Remember, the explicit rule is the one that lets us find any term in the sequence. So if I want to find the 55th term in the sequence, I just have to plug in 55 for n, and that'll let me find what that number is. And it has a couple of different pieces. First, it has A1, which you've seen before, which is the first term in the sequence. So for these above, 3 would be A1 and 4 would be A1. Those would be the first terms in the sequence. The term number, that's going to be n. That's whatever you're looking for. So if you're looking for the 51st term, then the term number is 51. And then we've got the common difference, which is going to be whatever we're adding or subtracting over and over and over again. That's the d value. So in this case, it would be +3, +3. In this case here, it would be -2, -2, because that's what the pattern is, and that's the d value. You've got a similar situation going on with the recursive rule below. It has two parts to it. Okay, first, it's got A1, which you'll have to list. So A1 is the first term, so whatever the first number is. Okay, and then it's got AN equals AN minus 1 plus D, which you saw yesterday. And we'll talk about how to set this up. The thing you need to remember is that you need to know what the D value is. We'll come back to those, right, when we start to set them up ourselves. So let's check it out. It says, tell whether the sequence is arithmetic. If it is, what's the common difference? So remember, to be arithmetic, that means that we're either adding or subtracting the same number over and over and over again. So if I look at 2, 4, 8, 16, this is multiplying by 2. So this is not arithmetic. So I'm going to put no there. It is not arithmetic because we're multiplying there. Okay. Whereas letter B, we can see we're adding 2 and adding 2 and adding 2. So this is, yes, this is arithmetic. And the D value is 2 because that's what we're adding over and over and over again. Moving to letter C, we go from 20 to 10 to 5 to 2.5. So it looks like we're cutting in half, right? So we're multiplying by 1/2. And remember, multiplication, that's not arithmetic. So this is another no. And letter D, we can see it looks like we're subtracting 3, subtracting 3, subtracting 3 to get from one term to the next. So this is, yes, this is an arithmetic sequence, and D equals -3. Okay, it says you can order tickets for the local theater online. There's a fee of $2 per order. Matinee tickets cost $10 each. The total cost in dollars of ordering N. Matinee tickets online can be found by using this function over here. Okay, so for this one, it's asking me to fill in this table, right? So we had something like this yesterday, so I'm going to go ahead and punch these pieces in one by one here. So if I plug in 1, my first output is going to be 12. And if I plug in 2, we're going to be at 22 and 32 and 42 as I plug those things in for n. What's the domain? What's the range? Remember, the domain is the x values. So that would be 1, 2, 3, and 4. And the range is the y values. So that would be 12, 22, 32, and 42. What's the first term of the sequence? So this is going to be, in this case, they're using C, so I'm going to put C1, the first term. Well, that's going to be 12 because we're looking at our outputs there. And what's the common difference? When they're asking for the common difference, they want you to look at the range here. So as you can see from our range, it looks like we're adding 10 each time, right? Adding 10, adding 10, adding 10. So our common difference, the D value, is going to be positive 10. All right, keep moving here. We're going to start to set some of these up here. And so they're going to give you a table and they want you to write these arithmetic rules. There's two kinds, remember from the table before. I'm going to go ahead and write what those pieces are, just because we can't see them on the screen right now. Okay, so from the other page, the recursive looks something like this. A1 equals, we've got to fill that piece in, and then it says AN equals A n minus 1 plus D. And the explicit rule, which is a different version of this, is AN equals A1 plus n minus 1 times D. Okay, and so if you slide over to the steps here, it says identify A1. So that's the first term in your sequence. Identify the common difference, that's D, and then we're going to plug those two pieces in, A1 and D. So those are the only things that we need to plug in to set these up. Okay, so I need to plug in A1, which we've left a blank spot for, and D, and then I have that thing set up. Same thing on the other side, right? I need to know what A1 is, I can plug that in, and what D is, and I can set these formulas up. So let's do it, starting with the recursive rule. So A1, if we're looking at our table here, remember we're looking at the outputs, the range. So A1 for this one is going to be 2000. That's the first term in my sequence. So I'm going to write A1 equals 2000. And then the other stuff I have to fill in, this looks like this. AN equals AN minus 1 plus whatever the common difference is. So if I check out my table again, it looks like for my common difference, I'm adding a number. I'm adding 500 each time, right? Adding 500 each time. And so that's my D value there. So I can go ahead and add that to my rule. And that's all they're looking for right now for the recursive rule. Okay, and so basically what you're doing is you're setting yourself up for future success here, because if they were like find the 55th term in your sequence, then you would plug in 55 for n, right? And you'd go ahead and solve for it. But right now you're just setting the rule up that would help you do that. Let's do the explicit rule. We've got AN equals A1, which you already said was 2000, plus n minus 1, we're not touching right now, times D, which is 500. Okay, and again, if they said find the 55th term, well then you would have to go ahead and plug in 55 for n and go ahead and solve this thing. Okay, and so then it would take a little bit of work. But right now you're just setting up the rules, that's all. Okay, we'll keep moving here. Check out the next one here. Same idea. So the recursive rule, we need two pieces. First, you need to list what A1 is. So hopefully you're looking at our table here and you're remembering A1 is the first term, which is 5,000. And then we have AN equals an minus 1 plus whatever the common difference is, so whatever we're adding or subtracting. In this case, it looks like we're adding 1,000, right? And we keep doing that, so that's my common difference. That's my d value, so plus 1,000. And again, we're just setting that part up. Moving to the explicit rule, we've got an equals, remember it starts with a1, which is 5,000, plus n minus 1 times d, which is 1,000. Okay. And that's all you need. That's all you need for that part there, right? If they were to say, okay, well, it looks like for this one, right, we have months 1 and 2 and 3, and it keeps going to 4 and 5, right? What if they were like, well, how much is your bank account going to have in 27 months, right? So if they said, well, how much is it going to have in 27 months, right? So I'm going to put find amount in 27 months. Well, then you're going to have to plug in 27 for n. Right, so you're going to punch in 27 for n, and then you would have to solve it. So we'll go ahead and do that real quick. So this is going to be a of 27, which is the 27th term here. So we're going to end up with 5,000 plus 27 minus 1 times 1,000. And then we're going to go ahead and evaluate here. So it's going to be 5,000 plus 26 times 1,000. Okay. And of course, that's going to give me 26,000. So we have 5,000 plus 26,000. And then we can go ahead and add this all up, and we'll be at $31,000 in month 27. Okay, so right now you're just getting used to setting this part of it up, this formula up, right, so that you could go ahead and evaluate at a later time. All right, let's move to the last page here. It says write an explicit rule, so just the explicit rule in function notation for arithmetic sequence. All right, so remember the explicit rule looks like this: an an equals a1 plus n minus 1 times d. All right, so if you look at this set of points that we have here, we'll zoom in a little bit. We can see that the first point that we have is 75, right? That's 1 comma 75. So that's going to be a1. And then our d value, well, you can see we're going from 75 to 100 to 125 and so on, right? So we can see that we're going up by 25. And so then my formula would just be that an equals 75 plus n minus 1 times 25. And we end up with our answer there. All right, we'll keep going here to the next one. Same idea. So for this one, our a1 value is going to be 6, right? We can see that's the first piece there. So I'm going to set this up. An equals 6 plus n minus 1. And then whatever the d value is, so we're going from 6 to 9 to 12 to 15, so that's going to be 3. And so then that's all we need for that one is our formula. Looks just like that. And we're good to go. All right, we'll finish these last two up. It says, what information do you need to write a recursive or explicit rule for an arithmetic sequence? So there's two pieces of information that you need. Hopefully you remember. This is going to be A1. Let's try that again. We need A1, which is the first term. And we also need D, which is the common difference. Okay. It then says, which rule would you use to find the 19th term in a sequence and why? So remember, there are two options. You can use the recursive or you can use the explicit. In this case, it's going to be best to use the explicit, because remember, the explicit is the one that allows you to find any term, right? So you can just punch in 19 and you can find it, whereas the recursive, like we talked about yesterday, requires you to go one by one, and you would have to go 1, 2, 3, and work your way and find each one of those. Okay, but the explicit just lets you punch in 19 and you're done with the whole thing. All right, thanks for watching.